Artificial intelligence refers to the ability of machines to perform tasks that normally require human intelligence, such as recognizing patterns, making decisions, and learning from experience. In this video, we'll explore the key milestones and breakthroughs in the development of AI, as well as some of the challenges and controversies it has faced along the way. Early years. The concept of artificial intelligence can be traced back to ancient myths and philosophical debates about the possibility of creating artificial life, such as the Greek myth of Pygmalion, who created a statue that came to life, or the Jewish legend of the golem, a clay figure animated by magic. The ancient Greek philosopher Aristotle explored the idea of automation and self-moving machines, while the poet Homer described the golden maidens of Hephaestus, who were made of gold and could move and talk. Aristotle believed that machines and workers didn't need advanced intelligence to do their jobs. He also thought that using machines to do work was only a good idea if there was a very powerful ruler in charge. However, he also suggested that in more free and fair societies, machines could be used to replace workers. In the Middle Ages, the Spanish philosopher Ramon Llull proposed a method for generating knowledge using a mechanical device called a combinatorial machine, or simply put, the thinking machine. Llull came up with a system of thought to help people in debates about religion and other intellectual topics. He aimed to create a universal language by combining logical terms. He made a tool consisting of 7 paper discs, each with a list of concepts, such as attributes of God. By rotating the discs, people could generate answers to theological questions. The machine was intended to help scholars and philosophers organize and analyze their ideas more systematically, and to aid in the discovery of new knowledge. While Llull's machine was never constructed, his concepts influenced future advancements in logic, philosophy, and computing. AI's modern history started with the development of electronic computers in the mid-20th century and the emergence of cybernetics. Cybernetics aimed to comprehend and control complex systems using feedback mechanisms. Norbert Wiener, a mathematician and engineer, is widely considered as the founder of cybernetics. In his book, Cybernetics, or Control and Communication in the Animal and the Machine, 1948, Wiener explored the similarities between human and machine communication and proposed a new science of control and communication. Wiener's work later influenced and inspired a generation of scientists to think of computer technology to extend human capabilities. During the 17th and 18th centuries, the world was undergoing a significant transformation in science, philosophy, and technology, known as the Scientific Revolution. This period marked the birth of modern science and the rise of rational thinking, which led to the development of innovative tools and machines. Blaise Pascal's mechanical calculator, also known as the Pascaline, was one of the earliest mechanical devices that could perform mathematical calculations. The device used a series of gears and dials to add and subtract numbers, and it was widely used in business and scientific circles during the 17th and 18th centuries. The late 18th century saw the development of the steam engine by James Watt, which was a significant milestone in the history of automation. The steam engine provided a reliable and efficient source of energy to power machines and tools, making it possible to create factories, mass production, and ultimately, the Industrial Revolution. With the rise of automation, the idea of replacing human labor with machines gained popularity, and inventors and entrepreneurs worked towards developing machines that could perform tasks more efficiently than human workers. This led to the emergence of the modern manufacturing industry. In the mid-20th century, researchers such as Alan Turing and John McCarthy proposed the concept of machines that could simulate human intelligence, laying the foundation for AI as a formal field of research. Turing proposed the Turing test, to measure a machine's ability to exhibit intelligent behavior that is indistinguishable from a human. He also proposed the idea of a universal machine that could perform any computation that could be carried out by a human. Meanwhile, McCarthy organized the Dartmouth Conference in 1956, considered the birthplace of AI as a formal discipline. At the conference, researchers outlined goals, challenges, and techniques for achieving intelligent machines. The term artificial intelligence was coined at the conference by McCarthy, Minsky, Rochester, and Shannon. The conference led to a surge of interest and funding in AI research in the 1960s. The development of the first chess-playing program in the 1950s was a significant achievement in AI research. Claude Shannon and his team created the first program that could play chess, demonstrating that computers could be used for complex decision-making tasks. This program paved the way for further research in the field of machine learning and decision-making algorithms, leading to the development of modern AI systems capable of playing complex games such as Go and poker at a superhuman level. The creation of the first machine translation system in the 1950s and 1960s was another notable achievement in AI research. This system aimed to automatically translate text from one language to another, and while its accuracy was limited, it laid the foundation for modern machine translation technology. Today, machine translation is widely used in industries such as e-commerce, travel, and international relations, making it an essential tool for businesses and governments around the world. This optimism and enthusiasm of the early AI researchers, combined with the significant progress made in the field, led to the establishment of AI as a legitimate and exciting field of research and development. The AI winter. In the 1960s and 1970s, AI faced a period of decline and skepticism known as the AI winter. The setbacks were due to unrealistic expectations, lack of funding, and disappointing results. Many of the early AI programs were limited in scope and performance and could not match the complexity of human intelligence. As a result, some critics argued that AI was a dead end and that resources could be better spent elsewhere. Some examples of the mentioned setbacks are as follows. In 1966, the Automatic Language Processing Advisory Committee, ALPAC, a committee of 7 scientists led by John R. Pierce, did a review. It is to evaluate the progress in computational linguistics in general and machine translation in particular. They published a report stating that the machine translation systems were not practical or cost-effective at the time. In the 1970s, there was a growing interest in connectionism, which is an approach to AI that models the brain as a network of interconnected nodes. However, the limitations of the hardware and software available at the time made it difficult to develop and test connectionist models, leading to a decline in interest in the approach. From 1971 to 1975, the Defense Advanced Research Projects Agency, DARPA, funded the Speech Understanding Research Program at Carnegie Mellon University. It aimed to develop a system that could understand natural language spoken by humans. However, the program failed to achieve its goals, leading to frustration and disappointment. In 1973, the Lighthill Report, commissioned by the British government to evaluate the state of AI research. The field was criticized for not producing practical results and recommended a reduction in funding. This led to a large decrease in AI research in the United Kingdom. In the USA also in 1973, DARPA cut back on funding for academic AI research in general, which had a significant impact on the field. However, some researchers continued to pursue AI research and made important contributions to the field. The development of expert systems and knowledge-based systems in the 1970s and 1980s provided a new avenue for AI research. It also demonstrated the potential of AI to solve practical problems in various fields. These systems relied on large amounts of domain-specific knowledge to reason and make decisions, and they were successful in certain applications. Despite these successes, AI still faced significant challenges during the AI winter. Funding for AI research was declined, and many researchers left the field or shifted their focus to other areas of computer science. Until the 1990s, with new techniques like neural networks and deep learning, AI research began to see a resurgence of interest and investment. Resurgence of AI. The resurgence of AI in the 1990s and 2000s was marked by significant progress and achievements in the field, driven by several factors. The availability of more powerful computers and specialized hardware enabled the training of large neural networks. Together with the emergence of new algorithms and architectures for deep learning, machines are able to learn from massive amounts of data and perform complex tasks. For example, image and speech recognition, natural language processing, and game playing. Additionally, the application of AI to real-world problems in various domains such as industry, medicine, finance, and more, demonstrated its potential for creating value and improving efficiency. Some of the notable breakthroughs and milestones during this period include the development of backpropagation for training neural networks, the creation of the World Wide Web that facilitated the sharing and distribution of data and knowledge, the emergence of big data, and the advent of cloud computing. There were also several achievements in the field such as IBM's Deep Blue computer defeating world chess champion Garry Kasparov in 1997, the development of Google's PageRank algorithm in 1998, and the breakthroughs in speech recognition and natural language processing achieved by companies such as Microsoft, Google, and Amazon, which enabled the development of virtual assistants and chatbots. The emergence of self-driving cars and other autonomous systems, which rely on AI to respond to their environment and make decisions in real time, was another significant achievement during this period. Current state of AI. AI is a rapidly evolving field with numerous applications and implications for society and the economy. Today, AI is being increasingly used in various sectors, including healthcare, finance, transportation, and more, to improve decision-making and outcomes. However, there is also a growing concern over the ethical, social, and political implications of AI, such as bias, transparency, accountability, and job displacement. One of the significant trends shaping the current state of AI is the ongoing research and development of new AI algorithms and architectures, such as reinforcement learning, generative models, and neuromorphic computing. These new approaches are enabling AI to tackle more complex and diverse problems and have the potential to revolutionize various industries and domains. Despite these advancements, AI still faces significant challenges and limitations. One such challenge is addressing the limitations and biases of current AI systems, which are prone to errors and inconsistencies. There is a need to develop more robust and interpretable models that can handle uncertainty and complexity better. Overall, AI has come a long way since its inception, and there is no doubt that it will continue to shape and transform various aspects of our lives in the future. However, it is essential to address the challenges and opportunities that come with AI and to ensure that its development and deployment are done in a responsible and ethical manner.